All right, greetings everyone. Um, so today we're going to review a bit of what Jeff talked about in class yesterday, which was the primitive data types, but specifically their class companions. Um, you may have accidentally typed in like an uppercase B for Boolean or a or an uppercase D for double or something along those lines. And for some reason, your code continued to work. And maybe you just ignored it and you just kept going and it was all good. But we're going to actually explore why that was. Um, and so we'll do a little review of primitive data types, what we have to work with in Java, and then looking at their class companions. Um, and then we'll look at the Java object class, and then explain why that's super important. All right. So yeah, so everything's good in Jeff Land. His website's up, and I'm able to SSH in the server, and hopefully you've done assignment 5 and that you've started to look at assignment 6. And then send me requests if you have any requests. Okay, so there's a lot of text here. We're just going to take this a bit at a time. So all of this you should be pretty familiar with. I just posted the ranges of what these things are. So like a byte, it's an 8-bit sign 2's complement. That just means that this sign 2's complement, that just means that it can have, it can be positive or negative. But really all we care about here is the minimum value and the maximum value, and the word inclusive, that we can actually store this value. Because a lot of times when specifying ranges, people will omit the endpoints, and then they won't say inclusive if the endpoints aren't included. So yeah, so bytes, it's 8 bits, and it's negative 128 to 127. And the reason being is because 0 is a value that it can hold, and so that 0 takes up what we could otherwise have given to that 128 here. So it's all of that range there. Okay, one sec. All right. Okay. So yeah, and then the same with all of these other types, that we should be familiar with them. Hopefully we've used most of them in our code. Maybe not shorts, but shorts, they're just smaller integers, right? And actually this has a minimum value and a maximum value. So this is exponent, an exponent that's not being displayed. But so an int is massive, and then longs are also even more massive. Okay, and these are integers. All of these here, the byte, the short, the int, the long, they're all whole numbers. Down here we get into sort of sketchy territory with the floats and doubles. These are floating points, so these are where we have these decimals. And really, the only reason why you use a float is if you had memory constraints, or you wanted to process something very quickly but didn't care about accuracy. We tend to use doubles a lot more because they're double precision. They're a lot more accurate, and that they're less prone to rounding errors than we see in floats. And you can easily test this yourself. Like you could plug, store something as a float, and add some things and subtract some things that are symmetrical, like that they're the same. And go to look at what the float is, and you'll notice that it's lost its precision pretty quickly. Versus a double is going to hold on to it much better. It still can lose precision, but it's less likely. But it's still pretty easy to force. Okay, and then booleans, it's just the true or false, so 1 or 0. And then chars are much bigger than in other languages. They're these 16-bit Unicode characters, and so there's a lot of them. Versus in ASCII, like most characters in other languages, ASCII is much bigger. Unicode is much bigger than ASCII, because it tends to only use 8 bits, versus Java's char uses 16, so it's double the number of bits, but it's a power of 2 in the sense of the number, or it's a few powers of 2, right? It's 8 more powers of 2, more values, because of that. Okie dokie. So all of these should have class companions. And so let's just open up a terminal. Go to Jest website. Okay, and then let's open up JShell. Zoom in a bit. All right, so if we make a normal byte, we'll call NB normal byte, and then we can say like 5 or something like that, right? And then if we try to do anything with it, we can do like addition and stuff like that. But the thing is that if we say this dot, and then we hit tab, there's nothing available to us because it's a primitive type. Now, if I say byte with a capital B, and I say class byte equals 5. Now if I say CB dot, I notice that I get all of these things, but I could also just do like CB plus 1. Right? So I can do the same kind of operations that I could do with the primitive type, but now I have a lot more because suddenly it's a class. There's all of these methods that belong to this class that allow us to do things with it. They'll get the bytes value, and so what's cool is that if we try to use it, like if we try to do addition and whatnot, it's essentially doing this behind the scenes for us. It's getting this byte value and then is able to, it's able to convert it. And so this here, double value, so if I was interacting with it as a byte, if I was to adding it to a byte, for example, it would use this. If I was trying to add it to a double, it would use this, or a float, it would use this one behind the scenes, which is pretty nifty. And actually, in this case right here, it used this int value. So essentially, this, when we called CB, what happened was that it was calling int value plus 1 behind the scenes. We didn't see that happening, but that's really what's happening right here for the class byte versus the primitive byte. And so there's other things that you can do. You can use some of the classes you might see more. For example, the integer class that we'll look at. So let's look at the integer class because there's a lot more going on in the integer class. So we'll call it basic int, or what was I calling things? Normal. So we're going to call it normal int, not ni, the knights who say ni, equals 5. Then I can do, the normal stuff. But if I say ni dot and then tab, nothing's going to happen because it's a primitive type. But if I say integer, hopefully I spelled that right, and then ci equals 6, whatever. Oh, did I misspell integer? Int or jur. There we go. Okay. So all right. Now I can say tab, and then I've got a few more things going on. Right. Compare to, equals, hash code, notify, short values, toStrings, things like that. Cool. So, and you're going to see a lot of these where essentially it's going to, whatever the internal private part is, isn't going to be revealed to us of it. If we recall from some of the classes we did, like Pokemon, the one that we did in the previous session, there were lots of private parts to the class. But hopefully we didn't, maybe we had setters and getters for that. But we could have hidden that. We could have stored our HP as some other, we could store the HP as like an array of booleans, and then set them to true or false based on having HP. But then when somebody says get HP, what we do is we iterate through that array, and then we say how many, we count how many trues there are, and that tells them how, what the health is. So we can obfuscate, we can sort of hide how the behind the scenes implementation is. And that's exactly what all of these are doing, is that this integer class here, CI, we don't know what the private part is. We know that it's storing the number 6, but we don't know what type that it's storing the number 6 in. But what's nifty is that we can get that number 6 in lots of different ways. We can get it as a byte, we can get it as an integer, we can get it as a long, things like that. I mean, we can even get it as a string, right? Right? We got it as a string. Pretty nifty. Okay. So maybe you have a string, but you want to go the other way. If you recall, there's a string class. So we're going to make a string. We're just going to say string dot, and let's see. So we have the format join class. Let's go double check the API. So let's open up a terminal or a browser. Come on, browser. Okay. So Java API string. And we're playing with 13, right? Okay. So here we go. This is the good stuff. So there's lots of things that deal with strings, but then there's also stuff that allows us to get things as bytes and as characters. And then there's these values of here. So if we go back to the terminal, we see this value of, that's the good stuff. This allows us to take a string, or to essentially give it a parameter of a type and get it as a string. That way maybe we can print to the screen or whatever. Or display it in a text box. So it's really important to be somewhat familiar with these classes that we're using, because they're pretty powerful, and they're just adding tools to your tool belt. You don't want to spend a ton of time saying, like, I have this data, but I need it to be in this type to be able to put it in this other bin in order for me to display this in an app or something like that. You're going to be spending a lot of time manipulating data types of stuff so that they're compatible, so that you can stick them together or whatever. Okay. There's one other thing that I wanted to look at. Just scrolling through here to see what. All right. So now I remember. So this was in the string class, but one of the things that we can do is we can take a string class instance, and we can use it with those other classes that we were looking at. So for example, if we go back to our example of our integer class, right? Here we have our integer class. There are some things that you don't need a class instance to do. So if we just hit tab, there should be something called parseInt. ParseInt. And notice that there's a signed and an unsigned int. We're just going to go with the signed. That just means that it's negative or whatnot. And this can take strings. So we could feed it like the number 5. And we're going to get the number 5. And we can use this to store this in, in that guy, in our class integer. Or it could just be in our normal integer. That's what's nifty, is that the way that the class and the primitive data type work is that they try to be very inclusive, that the class can do everything that the primitive data type can. So this is nifty because we can make a string, right? We have a string called nums live here, and I can store the number 9001, and then I could call parseInt on nums live here. Pretty cool. So we're able to take things that are strings and convert them to numbers, and all of the classes have this functionality, of the primitive type companion classes. Cool. So yeah, so that's really important, because that kind of encapsulation is what we're going to be doing for a lot of our programs. Okay, let's talk about the almighty object. So something that everyone should know is that in Java, everything eventually inherits from object. Everything, except for the things that don't. But in our case, everything within this class that we're in right now, everything is going to inherit from this guy. So every class instance that we interact with will have these methods available to us. And one of the nifty things is that if you don't like what's been provided, you can rewrite it. You can do what's called overloading, where you essentially, or overriding, where you are rewriting this method to do what you want. For example, this toString, the generic toString, so everybody gets toString. So when you make a new class, it has toString. The thing though is that maybe when you call it, you get some just gobbledygook, because typically what happens is that it prints out the spot in memory where it lives, or this hash, or actually in this case it's a hash of, it's called the hash code, which all class instances have, and then to hex string, so that displays it as a hex value, which if you recall from the previous session, and then gets the class name. So we can look at that. We can say like, oh, well, what's this hash code doing? Returns a hash code value of the object provided by hash map. So typically these tend to be, it's a hash, but you can sort of think of it as, so this hash map is essentially telling us uniquely where in memory our object is living, because we don't have any kind of visibility to any of the to how memory is mapped in Java. So if you ever wanted to compare two objects and seen it where they live relative to each other, or sorry, that's it won't do that. If you wanted to see if they're the same, so if you have two objects and you're like, and maybe you found them in different ways, and you wanted to make sure that they were not the same or they were the same, you could use this hash map, or you just call hash code and you compare the two to tell whether or not they're the same object. And you can also overwrite this so that hash code is only hashing specific parts of the class. All right, yeah. So everybody has this functionality. So one of the nifty things though is that as you're inheriting things, Jeff talked about arrays a bit, and he also talked about their inheritance structure, and a little bit about sets as well, where they essentially are inheriting all of their parents' stuff. So like let's look at array. We want the util arrays. So if you notice that arrays inherits from object, but there's I think it's called container. See, that's in swing. Oh, collections. Java util collections. So this again, here we go, list. That's what Jeff was talking about. Sorry, it took me a while to remember where he was at. So, so list, Jeff talked about a bit, and if you recall, he may have said some of these words, and it's okay if you don't know any of these words. That's perfectly fine. That's most of that's next semester that you'll be playing with that stuff. But essentially, there's this list, which is pretty much like an array, and it has all of this nifty stuff. It has adding, it has clearing, it has contains, it returns a boolean, is empty, things like that, that allows to interact with it very much like an array. I mean, this is pretty much an array, but it's got a little bit more going on. If we go back to our arrays, right, we've got lots of searches and compares. I mean, we've got a lot of stuff here because it's sort of written generically so that it can take, you know, we've got like 10 different sorts, for example, that are all overloaded. But this doesn't have everything that you might want. And so depending on how you're using that array or just glob of data, you might look at one of these guys here. Maybe you want everything to be, maybe you want an array that changes its sizes. Then you use something like an array list, where you don't have to care about its size changing because it's hiding that in the class. It's using this list, this abstract collection from object, which is pretty much an array. The array list essentially has an array inside of it, but it's hiding that from you and only giving you these very basic ways of interacting with it. Cool. Or maybe you want, somebody asked a question in class yesterday, what about duplicates? And one of the things that Jeff sort of mentioned, but didn't say that you had to use it or anything, is called a set. And you notice that the set, it's part of, yeah, I just clicked to get here from the abstract list class to get to set because it implements it. And all it is essentially, you can think of it as a list or an array that doesn't allow duplicates. But with the set, one of the weird, unique parts of it is that it doesn't care about the order of things. So maybe the order that you put things in doesn't correspond at all to the order that it's stored in on the system. And then notice that in this set, you can convert it to an array, or you can have it return an array. So it iterates through, and then it gives you it as an array. And now that array is going to continue to stay in the order that it's in, but that from the next moment, maybe you call this toArray again, a few seconds later, whatever this class returns, you're not guaranteed that it's going to return everything in the same order that it returned before. So that's one of the nifty things about sets, mainly because sets, the order isn't important about in regards to the data. Yeah, so those are some objects that are useful. And play around with the API. Look around. It's super useful just to know the names of some of these classes and some of the names of the methods. Even if you don't understand what they do or what they are, just being familiar with the names is gonna give you huge leg up. All right, so that's pretty much what I had for today. If anyone had any questions, but I think it's just me, myself, and I. All right. Yep. Okay, cool. So yeah, so that was primitive data types, and then we looked at some of the class companions, and then we looked at objects and some of the various objects, some of the things that inherit from object, which in this case will be everything that we're going to work with. Okay, that's what I got for you today.